Today our topic is relativistic mass. As we know that time basically change due to the relative motion. Length contraction, we have seen that length is also changing due to the relative motion. And in one more topic where we have seen the velocity addition, velocity also change. So in this particular topic basically we will try to show that mass also varies with respect to the relative motion. For this relativistic mass, we can imagine a physical situation in which we can say that we have this a moving object, this truck moving into this particular direction with the velocity v. In this truck basically there are two persons. That's have a ball in the hand of this man. This is a ball suppose b1, mass of that is mass m, and velocity by which this man throw into this particular direction, that is suppose u prime. One more man here, this second ball b2 for an example. Mass of this ball is again same, speed will be u prime, but this time speed is negative with respect to the driver because of that truck is moving into this particular direction. So this man throw a ball and this man also. The speed of the ball is u prime, that is same speed, that is u prime, same mass of the two ball, that is m. So the point is basically we have to explain relativistic mass with this physical situation where we are considering two balls b1 and b2 of the same masses m and have this velocity u prime in a moving frame. So this truck basically is moving, that's we are saying this is equivalent to a moving frame. Now before collision what happens? This m before collision which we are considering here, that is inelastic. This is inelastic collision we are considering here. That means kinetic energy of the system before collision and after collision is different. So that is the meaning of inelastic collision. So before collision, according to this situation, m u prime plus m minus u prime is the total linear momentum. After collision basically what happens in this situation, we assume that when these two balls are perfectly elastic and when the collision take place, so they both stick together and form a single ball. Mass of that ball is m plus m, and this particular time basically what happens at this particular time, speed of this ball basically which form due to the inelastic collision between this ball B1 and B2. At that particular moment it stops. So I am saying that speed is 0 right now. So now I have to basically interpret this physical situation in terms of the coordinate system. So this is the S prime frame which is moving with the speed v. This is x prime axis, y prime axis, z prime axis, and at this is the origin O prime, where O prime observer basically is situated. So this you can say an observer O prime. So what happens, we are taking basically two balls of same masses, ball B1, this is ball B1, this one is ball B2, are approaching to each other and each having the same mass m. In this frame basically that is S prime frame, and have equal speeds u prime and minus u prime. Minus u prime we are taking because this S prime frame is moving along the positive x axis. So the speed of this ball is opposite to that direction. That's why into this frame of reference, in S prime frame, the speed is minus u prime. So u prime is the speed of both the balls, and that is same but in opposite direction. Masses of both the balls are same. So when they basically these two balls, this situation is the before collision. And now after collision what will happen, as we had discussed earlier, into that particular real situation, into the turf, both the balls stick together now after collision. This situation is after collision, and now mass of the ball is m plus m. And at this particular moment when both these balls basically collide, speed we can say that is equal to 0. This is suppose u1 prime. u1 prime is equal to 0 at any time t. So this is the situation after collision. Right now basically what we have to do, now we have to apply the law of conservation of linear momentum. Now applying the law of conservation of linear momentum. So what is the linear momentum before collision? That will be, according to this O prime observer, that will be m u prime plus m. For the second ball before collision, that will be minus u prime. After collision, this is the situation, m plus m, total mass of this ball, and speed that is 0. So the result will be mu prime plus minus mu prime, that will be 0. mu prime plus minus mu prime is equal to 0, and this is also 0 because speed is 0 here. So we can show here conservation of momentum. Now we have to find out basically this S prime frame is moving relative to the S frame. This is our S frame, and at the origin basically we can assume an observer here. This is an observer O. So this was the situation according to the O prime observer. Now we have to find out this particular situation of the collision of the two balls according to this man O. What he observed basically? He observed is speed of the ball B1 for the B1 according to O. According to O observer. What he says? He says about this ball, its speed is U1 and mass instead of this M, that is M1, because now we are considering that mass is changing due to the relative motion. So instead of this mass M, this observer O is saying M1, speed U1, and for the ball B2, this is ball B2, for this mass he is saying M2 and speed of that is U2. So now according to this man, the momentum before collision that will be M1 U1 plus M2 U2. After collision, what he observed? According to this O prime observer, because this collision take place into the S prime frame and he knows the actual thing, and he found at this particular moment at t speed of this ball, when both the ball basically collide at that time, this ball is in rest at t speed of this ball is 0. Now what he observed? This man basically observed speed of this ball at that particular moment v, because this ball is kept into this moving frame and this frame is moving with respect to s with the speed of v. As we have discussed earlier, that this ball, which is formed as a result of collision of these two balls b1 and b2 at particular time t, any particular time t, this ball basically appears to be at rest. Speed of that seems 0 at any particular time t after collision to these observers. But this situation occur into this moving frame. So this frame is moving, this truck is moving with this speed v. So the person who is standing across the road, he will observe the speed of this combination, basically a new formation of the ball, that will be appear v. That's why we are considering here speed of this ball, new ball after the collision v, because this frame is moving with the speed v. So observation of the O observer, that will be v, and mass m1 plus m2 v. So first of all, basically with the help of this equation, we have to find out the ratio of m1 and m2. But before that, what will be the value of u1 and u2? We know that ux is equal to ux prime plus v upon 1 plus ux prime v upon c square. So for the first ball, that is ball b1, speed of that ball is u1 according to the observer O, ux prime is minus u prime plus u prime plus v upon 1 plus u prime v upon c square. Because this is our ball B1, and according to this observer, he says the speed of this ball is u1, as we have considered already. So u1 is equal to this minus u prime plus v upon 1 plus u prime v upon c square. And for the ball, second ball B2, u2 will be equal to u minus u prime plus v upon 1 minus u prime v upon c square. So u2 is equal to, for this ball, that is B2, and according to this one, this is ux prime, that is minus u prime. So that's why we are taking here u2 is equal to minus u prime plus v upon 1 minus u prime v upon c square. Now from this equation and this one, we have to put the value of u1 and u2 in this particular equation. Suppose this is equation number 2, and this was the equation number earlier which we had discussed for the O prime observed, that was 1. Now what we have to do, we have to just put these value of u1 and u2 in this equation, that is m1 u1 plus m2 u2 is equal to m1 plus m2 and this v. So now putting this value, m1 u1 is equal to u prime plus v upon 1 plus u prime v upon c square plus m2, and u2 is equal to minus u prime plus v upon 1 minus u prime v upon c square is equal to m1 plus m2, and this is our v. So now we have to basically take common m1 and m2 together, m1 and this m1 together, m2 with this m2. So m1 for the purpose to find the ratio between m1 and m2. So m1 u prime plus v upon 1 plus u prime v upon c square minus this m1v minus v is equal to, now this m2 and this factor into the right hand side, this is m2v, so m2 common, v minus this minus u prime plus v upon 1 minus u prime v upon c square. So now we have to simplify this equation for the ratio of m1 and m2. So m1 u prime plus v minus this v minus u prime v square upon c square, and upon this factor 1 plus u prime v upon c square, and into the right hand side similarly m2 this v minus u prime v square upon c square minus plus u prime and that minus v upon this factor 1 minus u prime v upon c square. So from this equation, this result, one can see easily that we cancel out this minus v plus v, this plus v and this minus v, and again further u prime minus u prime v upon c square, and here this u prime minus u prime v square upon c square. So this factor is also common, so the completely we can cut it with this factor. So now what we have the ratio of m1 and m2 . Now m1 upon this 1 plus u prime v upon c square is equal to m2 upon 1 minus u prime v upon c square. And further simplification it, because we want ratio of m1 and m2, so this becomes m1 upon m2 is equal to 1 plus u prime v upon c square upon 1 minus u prime v upon c square. So this was the first step where we have found out the ratio of m1 and m2. Now what is the next point? For the next point, basically now we have to find out the result for this 1 plus u prime v upon c square 1 minus u prime v upon c square with the help of u1, that was u prime plus v upon 1 plus u prime v upon c square, and u2 is equal to u prime minus u prime plus v upon 1 minus u prime v upon c square. So right now our purpose is to find out the value for this 1 plus u prime v upon c square, and secondly 1 minus u prime v upon c square. For this, what we are basically considering here, we are considering this velocity component according to the Lorentz transformation. u1 is the velocity of ball b1, u2 is the velocity of ball b2 according to the observer O. Now divide it by c, both the side divide by c, so this will be 1 upon c. Instead of 1 upon c, one can write in this way also. Now take the square of it and also then square of it. Now subtract this square from 1 minus, and subtract this also 1 minus. Similarly for this, divided by this c, so you can divide this c, square of it, squaring of it, and this is square of this factor. Now subtract it from minus 1 and 1 minus this square. So this is our next job. Now we have to simplify this equation and this equation for the 1 plus u prime v upon c square and 1 minus u prime v upon c square. Now how to solve? This is a simple method, algebraic process, simple case, and for that basically I am selecting first of all this equation 1 minus u1 square upon c square, that is 1 minus this factor u prime plus v upon c and this one. So the result is 1 minus of u1 square upon c square is equal to 1 minus u prime plus v upon c whole square, and this factor 1 plus u prime v upon c square whole square. Now, simplifying it, so this term 1 plus u prime v upon c square minus 1 plus u prime v upon c square whole square minus this term u prime plus v upon c whole square, and this one 1 plus u prime v upon c square whole square. Now the next term will be, open this square, that will be 1 plus u prime square v square upon c4 plus 2 u prime v upon c square. Now open this square, that will be minus u prime square upon c square minus v square upon c square minus 2 u prime v upon c square, and divided by this factor, that is 1 plus u prime v upon c square whole square. So now this is minus 2 u prime v upon c square, and this is positive, so this factor cancel out, and further simplification, keep it v square upon c square with 1, so this becomes 1 minus v square upon c square, and this is minus u prime square upon c square, this is u prime square upon c4, take out this common minus, so minus u prime square upon c square, and from this is equal to 1 minus this factor, that is v square upon c square, and divide by the term 1 plus u prime v upon c square whole square, and from this you can say this is 1 minus v square upon c square, and now 1 here minus u prime square upon c square, divided by this 1 plus u prime v upon c square whole square. So this is the simplification of this term, 1 minus u1 square upon c square is equal to this one. Similarly, we have to find out the value for second one, 1 minus u2 square upon c square. So now we have to find out the value for the second case, that is 1 minus u2 square upon c square. So as we did in this case, that we have to just put the value and just simple algebraic process, so we can directly find out the result for this. That will be 1 minus v square upon c square, 1 minus u prime square upon this c square upon 1 minus u prime v upon c square whole square. So now we got both the result. This one also, that is from 1 minus u1 square upon c square, and for the second one 1 minus u2 square upon c square. Now the next step is divide this result by the earlier one, that is this one, this. Now the next step is divide it 1 minus u2 square upon c square divided it by 1 minus u1 square upon c square, and I am writing here directly because both the factors 1 minus v square upon c square, 1 minus u prime square upon c square, here you can see 1 minus v square, and both are same, so cancel out, and this term basically becomes this 1 plus u prime v upon c square whole square upon 1 minus this factor minus u v prime v upon c square